Hello everyone, welcome to our channel. In our last video, we have seen the introduction to chemistry. From today's video, we'll start with the basic concepts of chemistry. First, I will start with states of matter. In our last video, we have seen the definition of matter. In today's video, we'll study about the states of matter in detail with their classification and with examples. Okay, let's get started. We all know that matter is anything that has mass and occupies some space. The things what you can see around you all are matters only. For example, the motorcycles, bikes, car, tree, water, pen, book, box, the computer, these all comes under matter only. And matter exists in three different states. Those are solids, liquids and gases. We'll see about these three states of matter in detail. First, we'll start with solids. Solid is a state of matter which has a definite shape and volume. Means anything that has particular definite shape and which occupies some space and which has some volume of its own kind is known as solid. And how will be the particles arranged in solids? We'll see. Particles are nothing but those are the small fundamental units from which the matters are made up of. Here you can see particles have strong force of attraction. Here you can see in this image these small rounded shapes are nothing but these are particles only. How these are arranged? They are arranged in a compact manner and in an orderly manner. So why these are so much compact means because they have strong force of attraction. And next one is their interparticle space is negligible. Here the space between two particles is very negligible. Here you can see the space is very much negligible, means hardly you can find the space in between the particles. Next one is particles cannot move. Here, due to this rigid arrangement and compact arrangement, particles cannot move from one place to another place. They are restricted to their positions and they have high melting and boiling points. Due to the strong force of attraction, they have very high melting and boiling point. If you want to get the melting point and boiling point of any of the solid, you have to heat it for very high temperature to get the boiling point. So this is how the particles arrangement is seen in solids. Next one is liquids. Liquid is a state of matter that has definite volume but not definite shape. Here you can see that solids have both definite volume and definite shape, but liquids have only the definite volume but not the shape. So that's why liquids take the shape of the containers. If you, for example, if you pour the water in glass, it will take the shape of the glass. If you pour the water in bucket, it will take the shape of the bucket only. So that's why they have the volume only but not the shape. And why these have only the volume but not shape? Because of the arrangement of their particles. Here particles have force of attraction less than solids but more than gases. Here the force of attraction between the particles is less than the solids but which is more than gases. And particles can move. Here due to the presence of space in between the particles, they can move from one place to another place. And these have less melting and boiling points. Due to the less force of attraction between the particles, these show less melting and boiling points. Next one is gas. Gas is a state of matter that has neither definite volume nor definite shape. Gases are the one which don't have the shape also and volume also. They will take the volume of the container only and they will take the shape of the container only. The reason behind this is force of attraction is negligible. Here the force of attraction between the particles or the bonding between the particles is very negligible. Here the particles are not strongly bonded with each other, so that's why they move with very high speed because they have very much space in between them. from one particle to another particle, they have lot of space, so that's why they can flow very easily. And they have low melting and boiling points. Due to the negligible force of attractions, they show very low melting and boiling points. Here you can see the particular arrangement in 3 different states. As I mentioned earlier only, this is the arrangement of particles in solids. Here you can hardly see the space between the particles, and this is how the particles arrangement is seen in liquids. Here particles are not arranged in a regularly and orderly manner. Here you can see the space in between the particles, so that's why the force of attraction is less. And this is the arrangement of particles in gases. Here you can see the particles are seen in a random position, and we can see the lot of space in between the gases, flow with high speed than the liquids. Okay, now let's see next topic. In macroscopic or in bulk level, matter is again classified into 2 types. First one is pure substances, then next is mixtures. Pure substances are again classified into 2 types. First one is element and compounds, then mixture is classified into homogeneous mixture and heterogeneous mixture. Now let us see about this broad classification in detail. First start with pure substances. As their name only says, they are in pure form. Substances that are made up of only one kind of particle and have fixed or constant structure are known as pure substances. For example, the metals like copper, silver, or the water, gold, these all are examples for pure substances. In copper, silver, gold or water, you can see only the molecules of those kind only. For example, in copper you can see only the atoms of copper. In gold you can see only the atoms of gold. So these are in their pure form. And the constituents of pure substances cannot be separated by simple physical methods. We cannot separate the atoms or the molecules of the pure substances by simple methods. They require very high efficient methods for their separation. Next one is element. Elements consist of only one type of particle. Any of the element you take and which is made up of only one kind of particle, that is known as element. These particles may be atoms or molecules. If you take only atoms, means if you take oxygen, sodium, nitrogen, oxygen is made up of only oxygen atoms, and sodium is made up of only sodium atoms, and nitrogen is made up of nitrogen atoms. So these oxygen, sodium, nitrogens are known as elements. Next one is compounds. Compound is nothing but 2 or more atoms of different elements combined to form a compound. You can see here it's a clear distinction between the elements and compounds. Here elements are nothing but they are the pure form of one type of particles, but compound they have the 2 or more atoms of different elements. For example, water, carbon dioxide, ammonia, these are the examples of compounds. Water is made up of hydrogen and oxygen. Carbon is made up of carbon and oxygen. Ammonia is made up of nitrogen and hydrogen. Here in water, hydrogen is also a different element and oxygen is a different element. These both hydrogen and oxygen combine to form water. And in carbon dioxide, carbon is different element and oxygen is different element. These two different elements combine to form carbon dioxide. So compounds are formed by the combination of 2 or more different elements. Properties of compounds are different from the properties of elements. For example, in water we have hydrogen and oxygen, and hydrogen is in its element form, it is in gaseous state, and oxygen is also in gaseous state. When they both combine to form water, the water is in liquid state. So the physical property or the state of the compound will be completely different from those of their elements. Okay. Next we'll see about the mixtures. What are mixtures? 2 or more substances combine to form a mixture. We all know that mixture is nothing but anything that has two or more substances in it. Examples of mixtures are sugar solution, air, coffee, tea, etc. In sugar solution, we have two substances. One is sugar and another one is water. In air, we have many of the gases. And coffee, we have water, milk and coffee powder, etc. These are nothing but mixtures only. Next one is homogeneous mixture. The compounds completely mix with each other and their composition is uniform throughout the mixture. Homogeneous mixture is nothing but it's a mixture of two or more compounds only, but there the compounds which have there in mixture, no, those all are completely mixed with each other and their composition is uniform throughout the mixture. For example, in sugar solution you can see sugar is completely mixed with the water. We cannot separate the sugar and water, right? And their concentration of sugar is uniform throughout the mixture. In water, sugar is dissolved uniformly. So this is how the homogeneous mixtures form. Next one is heterogeneous. It's also a mixture of two or more components only, but here composition is not uniform throughout the mixture. Here we can separate the two mixtures easily. Means example for heterogeneous mixture is sand mixed with grains, or mixture of two grains like mixture of wheat and rice. In mixture of wheat and rice, we can separate the wheat and rice by hand picking or by other methods. So here we cannot see the complete mixture of the two components. This is known as heterogeneous mixture, and these mixtures can be separated by using physical methods such as hand picking, filtration and crystallization. By using some of these methods we can separate the mixtures. This is about the broad classification of matter. I hope you all have got the idea of classification of matter. Have a good day.